Good afternoon, everyone, and welcome. Seth Naeve here. I'm Soybean Agronomist at the University of Minnesota, and I'm here again today to talk to you about the quality of the U.S. soybean crop, and most specifically, the quality of the food type soybeans that we produce here and primarily for export to your country. We don't have a lot of time, so I'm going to jump right into this. There is a full presentation report that's available for you, and I hope you're able to follow along and look at the text that's been translated for you as we go through this presentation. There are numerous tables that detail specifics about each of the varieties that we received and locations that those came from. I'm going to hit the very highlights of those and just show some of the information at the end of this presentation. But I wanted to give you a broader context today about the quality of the overall soybean crop and how that affects the production environment, might affect the quality of a specific food type soybean that you might import from the US throughout the coming year. So here's a brief outline. We're going to talk a little bit about the weather. As we know, weather has a great impact on yields of crop plants, but it also affects the quality in a big way. So this is really important for us to look at. So again, to provide you some context about the quality of the upcoming soybean food crop. We're going to talk about historical protein and oil variations. Again, for those of you that have been buying soybeans from particular exporters or from particular areas, it gives you a reference point on where those soybeans might look or how those soybeans might look this year relative to previous years. We're going to talk about our commodity soybean survey results so you can see what happened across the US and where the high protein and where the low protein soybeans were. And then we'll talk about the food soybeans results. And again, we're not going to deal in very much detail on this last point, even though this is the whole purpose of this presentation. We're going to provide mostly the larger context in this presentation, and then we can follow through with some more detail in the report that's been provided to you. So weather events for this year, I think, again, this is an important thing to look at as we consider the crop and how it both produced high yields this year, as well as the impact on the quality overall. We did have extreme weather. There's always extreme weather in the U.S. To report, but I try to always give you an idea of what those bigger, broader impacts were. And so these are really the big 3 points from this year that are important for us. And a very important factor for us is record early planting. In Iowa and Minnesota, we had very exceptionally warm and dry weather in April and into early May. This allowed very, very early planting, 2 weeks or more ahead of schedule in Iowa and about 2 weeks in Minnesota. We also had early planting in Illinois, Indiana, Nebraska, and Wisconsin. So these are very important soybean producing states. So they produce about more than 50% of the US soybean crop as a whole, but they're also important food type soybean producers from these regions as well. Early planting does tend to help us produce higher yields, but we do see definite trade-offs in terms of protein levels. So we definitely see reduced protein with earlier planting, and this could be, we could have seen the effects of this in the season. We also had severe drought that was centered in western Iowa this year, and it extended across much of the central corn belt. We'll discuss that really briefly, as well as the extreme wind event, the derecho that we saw in primarily in Iowa, but extending into Ohio into Ohio through Indiana and Illinois. We had winds of excess of 110 to 140 miles an hour in this region, and more than $7 billion in damage. Okay, let's take a quick look at the soybean crop as a whole. So this is primarily a crop that's produced for soybean processing for meal and oil. But we'll start with the historical variation that we see in protein and oil. So here's a 10-year average. So this is the previous 10-year average of samples sent into our lab. You can see there's nearly 20,000 soybean samples sent into our lab between 2010 and 2019. And you can also see variation in the density of that color spectrums from darker blues in the east and south to lighter greens to yellow in the north and west. So we have a range of protein between 35, 36% protein in the eastern and southern parts of the Corn Belt, all the way up or all the way down to maybe 33% on average in the north and the west. But you can see it's not a perfect geographical trend. There are hot spots and low spots in terms of protein levels that are related to soil type and the local environments. So because this is a 10-year average, this basically gives us kind of a background level of protein that we might expect in any particular year. This is driven by environmental factors like soil type and rainfall patterns. So this is more about climate than it is about weather. So weather affects our individual years, but climate really affects the quality of these long-term trends. Shown here is a 10-year average of oil concentrations around the US. And because protein and oil are inversely related to each other because they make up such a large portion of the soybean seed, you tend to have higher oil concentrations where protein is low. But it's not always the case, and certainly as we go north and west, again to the upper left-hand corner of this figure, you can see we have lower oil concentrations in an area that also had low protein. So while we definitely have a negative correlation, it's not a perfect one. A little bit more detail about our 2020 results. This year we had a very, very strange overall protein and oil profile in our US crop. These weather events I mentioned earlier had a drastic effect on how the soybean crop matured, and that environment had a very large impact on the quality of the soybeans. So there's always trade-offs, as I always mentioned, between protein and oil. There's trade-offs between yield and these quality factors. And then there's always trade-offs between these quality factors and secondary and tertiary components of the soybeans. So it's very, very difficult to predict these, and this year is certainly no exception to that. This year we had protein concentrations that were reduced by about 0.9 of a point, so nearly 1 point from the previous year. But oil, interestingly enough, was up by 1.5 percentage points over 2019 levels. We had similar increases over the 10-year previous for oil, and slightly larger 1.2 points decline for protein relative to the previous 10 years. One way to look at this is to take a look at the protein and oil trade-offs by individual state. So there's a lot going on here. This is a figure that I haven't shown before. I thought it was important to provide this data for you this year in a graphical form. This is exactly the same data that you can find in Table 2 in the commodity report, but it does show you the variation that we see by state in protein and oil, and really the trade-offs. The size of these circles represent the relative production. So the diameter of each of these circles represents the production by each state. It's a little bit difficult to see, but in the upper right-hand corner, there's a blue and magenta circle. Those are Iowa and Illinois. So these are the largest two circles. They have very similar protein and oil profiles, very, very high oil, but pretty low protein this year. As you move down and to the right, you can see Minnesota in purple. Minnesota had increased protein levels, but decreased oil levels. So again, this trade-off. So there's an opportunity for buyers to look for trade-offs between protein and oil, and certainly for most food bean soybeans, we're going to be more interested in protein. So it may be that purchasers might want to be looking more towards soybeans that are sourced out of the Western Corn Belt, where we had good protein levels, but may not have as high as oil, simply because our overall oil concentrations were way up this year. Here's a figure showing the distribution of protein. So protein was quite different this year than previous years. The lowest proteins we saw actually were in northern Iowa, eastern Illinois. So kind of in the center of this figure, you can see these lighter values. These are important areas for food soybean production. So it'll be important for you to take a look and talk with your supplier and be sure that they have access to high protein soybeans if they've been sourcing soybeans from this region this year. On the other hand, those soybeans that are sourced from Minnesota and the Dakotas, will actually be pretty good this year relative to the historical. Protein would be very similar to the historical values. Oil, as we've seen over time, has a kind of a north to south gradient from low to high. And we see it very strong this year with very, very high oil concentrations in the south. These are difference maps, just so you have an idea of how the protein level might differ for a specific location. If you've been sourcing soybeans from northern Illinois, southern Michigan, for instance, we have an idea that those soybeans are probably 1 to 2 percentage points lower in protein from the commodities system than they would be normally. Now, food beans, as we'll see in a little bit, don't seem to be as sensitive to this, but you can see the trend there is for lower protein in this eastern Corn Belt region. In the western Corn Belt and the Northwest, those soybeans tend to be lower in protein anyway, historically, and they didn't differ from that. So overall, there was less variation in the US this year than previous years. It kind of flattened that response, geographical response. But you can see that those soybeans from Minnesota and the Dakotas actually performed not dissimilar from historical values. Again, oil is quite the opposite. These dark blue represent oil concentrations that were increased by 2 to 3 percentage points over the previous 10 years. So there's some areas that produce very, very high oil in their soybeans. For instance, in the southern areas where we have Kentucky and Illinois, or Kentucky and Tennessee, those had very high oil concentrations overall this year. Physical characteristics are very important for food soybean importers. So I wanted to mention how those variation that we see in this particular year. Incoming moisture this year was much lower in the west. So because we had very warm conditions during the fall harvest season, we tended to get very dry soybeans come in from our commodity survey. Those soybeans that matured later and we had later rainfall in the eastern Corn Belt tended to be quite a bit wetter. There's a lot of food soybeans that are produced in this eastern region, and it probably helps support soybean quality overall. We'll have less splits and less damage because those soybeans are likely harvested closer to a 13% moisture than the very dry regions in the east. Amino acids are important for animals, and they're very important for humans. And so it's an important factor to consider as we're producing these food products from soybeans to consider amino acid variation, because this will affect the overall nutritive quality of those products made from the soybean protein. Lysine this year looked quite a bit like what we see traditionally. We see higher lysine in the north and the west relative to the other amino acids. So this looks quite a bit similar to the long-term historical variation for lysine. But what's interesting is these areas didn't necessarily have low protein this particular year. So it's quite interesting for us to look at this data. We saw very different profiles for the amino acids this year relative to normal. Typically, higher protein soybeans tend to have amino acid profiles that are diluted out by arginine and other high nitrogen containing amino acids. We didn't see that this year as strong as we have in previous years. And again, I think it's due to this very high oil concentration. The soybean produced had lots of energy to produce that oil in the seed, but it really ran out of nitrogen to produce the protein. So we saw different types of amino acids in the soybean this year compared to previous years. This is the sum of 5 essential amino acids: lysine, methionine, cysteine, threonine, and tryptophan. These are often supplemented in animal nutrition diets with synthetics. Where we're not supplementing those for human foods, it's important to look at the relative abundance of those in the soybean meal. And we saw a different profile for these 5 essential amino acids, even than we did for lysine itself, which is very unique for us this year. We typically see a very strong correlation between lysine and the sum because lysine plays a large role. It takes up a lot. It's about 40% of these 5 amino acids. So the fact that we didn't see a strong correlation between lysine and these other amino acids means that methionine, cysteine, threonine, and tryptophan must have reacted much different this year than usual. Soluble sugars are important for soybean foods. Sucrose is the simplest of these soluble sugars. It tends to have a positive effect for flavor and for nutritive quality. Raffinose and stachyose tend to have create problems in some soy foods, but they also are beneficial for natto and other types of fermented foods. So, depending on the end use, you'll want to take a close look at our report to look at the variation that we see in sucrose, raffinose, and stachyose. But here's just a figure to show the variation in sucrose. This year, we saw a very distinct area of low sucrose where we had severe drought in Iowa. It's very interesting to see this pop up this year. We didn't see this in protein and oil. We certainly will see it in yield overall, but we did see it in sucrose. So certain environmental events will play a direct role and have a direct impact on certain of these compounds, but other things are very much more difficult to predict. A little bit about the food soybean survey, and again, we're wrapping things up here at the end of the presentation, but I wanted to give you an idea of what we did this year for our food soybean crop, and especially just draw your attention to the report. We sent out about 606 sample kits to 21 exporters, and we received about 267 back by October 31st to be able to analyze for our presentation here for you today. We're expanding this survey quite significantly. We're going to be offering much more detailed information in a database of these varieties in coming years. Or coming up later this year. So I think we're excited to show the expansive reports coming on later. But for now, this is the report that we're providing based on the data that we received from these soybean samples so far. And what we're looking at here is distribution of the seed size by region. You can see average seed size soybeans. So these are general purpose soybeans typically are often the most numerous. Again, most of our soybeans came from the Eastern Corn Belt. Most of our soybeans are from the average category. Large size soybeans utilized primarily for tofu type soybeans. So these are 23, 24, 25 grams per 100 seeds, or less numerous. You can see the protein levels, and we had good protein levels. They did not decline this year as much as we had seen in the commodity survey, but you also see very high oil concentration. So we did see an increase in oil concentration. This variation tended to be a little bit more damped in the food type soybeans. So clearly food soybeans are bred and developed and produced in a way to produce more consistent quality rather than quantity. And that's what we see in the food soybean report this year, is that we've got good quality soybean, even going up against conditions where we would normally see drastically reduced protein levels overall. We're also presenting as well, again, sucrose, raffinose, stachyose values that you can see in this table here, as well as the amino acids that I mentioned. So we're presenting all this data in detail, and you can feel free to look at how those varied by region, by seed size. Lysine itself varied very little. We saw just a little bit more variation in these 18 and these 5 essential amino acids, but we did see some variation this year across the region. So overall, the Western Corn Belt was really actually equal to the Eastern Corn Belt in terms of protein level. And again, this mirrored what we saw in our commodity survey. Those two regions produced exactly even protein levels. The commodity survey, of course, had much lower protein. Food type soybeans significantly higher. So we had good protein levels overall. When we look at these by region and seed size, we see just slight nuances in terms of the protein levels, but basically Eastern and Western Corn Belt had very, very similar protein levels in both average and large seeded size soybean seeds. And again, as I mentioned at the very beginning, these different classes and regions were weighted very differently. Again, more soybeans in the Eastern Corn Belt, many more seeds of the average seed size. So it's important for you to interpret these with some caution. We had one soybean sample provided from the state of Maryland on the East Coast. So this region was only represented by one individual soybean sample. So we can't put much weight on that particular sample impacting the overall region or state average. Oil, again, much higher this year than previous years in the Eastern Corn Belt, slightly higher than the Western Corn Belt. And slight differences in terms of broken out by seed size and region, but not very much. Soluble sugars, sucrose is definitely higher in the Western Corn Belt than the Eastern Corn Belt, and this is typical for us. What we see, we saw sucrose about 5% rather than 4.7 on the East. Large soybeans, again, for the tofu type, slightly larger or higher in the Western Corn Belt as well. Sucrose concentrations in 2020 were really similar to those in 2019. Again, if there are some food soybeans that are produced in some very distinct areas of Iowa, for instance, where we typically don't see a lot of food soybeans, we might see differences in those soluble sugars. But overall, I think the sucrose levels will be pretty consistent across most of these samples surveyed. So with that, I'm out of time, but I thank you for your attention. And again, I really wish that I could have been there with you in person again this year. I've met so many great people and have made so many friends over the years that someday soon, I hope that we can meet again in your country so that we can interact and we can discuss. I hope that you have some questions for us during the panel discussion. I'd be happy to take up any of those as we discuss any of these information in more detail. Thank you very much.